Good afternoon.
Hello.
Yeah, hi, good afternoon.
Good afternoon. Is it audible?
Yes, yes.
Right. Shall we start?
Yeah, we can.
Yeah. Right. So we completed 13 modules. So up to the 13 modules, we discussed about various object-oriented programming concepts, as well as we discussed about exception handling also. Right. In our today's class, we are going to talk about multi-threaded programming. That is, what is multi-threading, how a main thread will be created, how to create user-defined threads using thread class and runnable interface, and creating multiple threads, and what about the thread synchronization, and what about the thread priorities. So all these things that we are going to learn here in this multi-threaded programming, right? Now, coming to the fundamentals of multi-threading, what is meant by a multi-threaded program? Here you can see the definition for that. A multi-threaded program contains two or more parts. Here, that program contains two or more parts that can run concurrently. Those two or more parts can run parallelly, but each part can handle a different task. One part can do, suppose for example, three parts are running parallelly, three parts are running concurrently. One part can do multiplication, other part can do addition, other part can do division. That is, each part is doing its own task, or they can handle different tasks at the same time. So they can do this multiplication, this addition, and this division. All these three can be done simultaneously, can be done concurrently, right? The same time, all these operations can be done same time, making optimal use of available resources, specifically when your computer has multiple CPUs, right? So here mainly the multi-threading programming concept is introduced for optimal use of available resources. That is here two or more
Voice
parts.
will became very low, ma'am, suddenly.
Suddenly, no. Okay, hello.
Yes, ma'am.
How is the voice?
No, it's still low.
Low only, na?
Yeah.
I try to switch off this fan. Maybe because of this fan. Hello?
Yes, ma'am. Now it's
Now?
clear.
Now it's
Yeah.
clear, right. Now here, in case of multi-threaded programming, so here two or more parts can run parallelly. Each part can do a different task, and all the tasks can be done on the same time for optimal utilization of the available resources, right? So this is the main aim of multi-threaded programming. So multitasking, what is meant by multitasking? Multitasking is when multiple processes share common processing resources. So here, one process is doing this operation, other process is doing this operation, other process is doing this operation. These three are sharing a common resource, which is nothing but CPU. Here, first this operation starts using the CPU. When this operation is not utilizing CPU, when this is going to take input, at that time, so CPU, suppose if these two operations are not there, CPU sits idly. So we don't want to sit any resource idly. We want to use, we want to get the optimal uses of resources. In that case, so that CPU will be allocated to the second task, right? So after that, if it is also going for another, if it is going for using another resource, it is not using now CPU, it is going for another resource, for using another resource. In that case, so CPU will not sit idle. So that's why we assign CPU to this task. Like that, we are going to make the optimal utilization of the CPU by doing this multitasking, right? Now here the multi-threading extends the idea of multitasking into the applications where the applications can be subdivided into specific operation within a single application into individual threads. So I have written a single application program, right? This program can create multiple threads. Each thread can do its own specific task by sharing the resources, by optimal utilization of the resources, right? This is to be called as multi-threading. Now, how we can define a thread? So simply, we can define a thread as a lightweight process. So how we can define a thread? It is nothing but a lightweight process. A thread is nothing but lightweight process. So here you can see multi-threading. So thread 1, thread 2, thread 3, thread 4. 4 threads are running concurrently. Each thread can do its own operation, right? Now you can see that multi-threading in a programming clearly, right? Now next we are going to see thread life cycle. What are the different stages that are present in the life cycle of a thread? So here the thread undergoes different states during its lifetime, from starting of the thread to the ending of the thread. Starting of the thread means start doing its task, and ending of the thread means completing the task. So from this starting to ending of the thread, in its life cycle, it undergoes different states. What are those different states? So first one, new state, active state, waiting or blocked state, timed waiting state, and terminated state. These are the different states which may be present in the thread life cycle. New state, active state, waiting or blocked state, timed waiting state, terminated state. Here we have given a simple life cycle process of the thread. We can see the detailed life cycle later. First, let us see the simple life cycle. Here, this is the new state. That is, just thread was born. So just the thread was created. Here, this is the new state. And after this new state, thread comes into the runnable state. When we call the method start, it comes to the runnable state, right? Runnable means ready to run. It is not running state. Runnable means ready to run state, right? After we call the method run, it comes into the running state. It comes into the running state, right? Here, first thread creation. So we can create a thread using new thread. And when we call the method start, it comes into the runnable state. Runnable state is nothing but ready to run state. And when we call the method run, it comes into the running state. Now, if within the running state, if it is completed its task, directly it comes to the dead state or terminated state, termination state. Okay, we can call the dead state as the terminated state also. Right. So if it completed its task, it comes to the dead state. If it is not completed its task, it is waiting for some other resource has to work for completing that task. It comes to the waiting state. That waiting state can be implemented by using these two methods, wait method and the sleep method. And some more methods also there. So mainly here we are using wait method and sleep method. This waiting method, sometimes it may be timed waiting, sometimes it may be normal waiting method. So here we mentioned two, timed waiting and normal waiting. These two comes under the waiting state. So I hope that you understand the simple life cycle of the thread. New, runnable, running, waiting, and dead states. Now you can clearly see the complete picture of the thread life cycle here. So here you can see. So first thread is created, new thread, and so when we call the method start, so here when we call the method start, it comes to the runnable state. So it is waiting, ready to run. It is waiting for the CPU. Whenever the CPU is allocated, this comes to the running state. That is the runnable state and running state. Both are to be called as active states. Now, when we call the run method, so this running state will be invoked, thread runs. If the running state is excited, then it terminated. The thread can be terminated. So, but meanwhile, sometimes it may be, it has to wait for something to happen. So that is, for example, I said that I want to do a bank transaction. I want to do a bank transaction. So initially, I have an amount of 1,000 rupees in my account. Now, I want to deposit some amount into my account. Now, I want to deposit 500. So this is one thread. This is the work of one thread. Doing the deposit is the work of one thread. So whenever I did the deposit, this deposited amount should be updated into the savings account. That is, the amount should be updated as 1,500. This updation should be done by another thread. Right. Now, when I want to withdraw the amount, so if I go for another thread, which is withdrawing the amount, now if I want to withdraw the amount 1,000 rupees, so this is done by one thread. After withdrawing this 1,000 rupees, the amount should be updated. That is done by the another thread. So here three threads are working parallelly. One thread is deposit, another thread is withdraw, another thread is updating. Right. Now, if you want to do the updation, if you want to make work the thread updation, either I need to do deposit or I need to do withdraw. Without doing these two, we cannot do any updations. Right. In that case, the update thread is in the waiting state for the notification from either deposit or from withdraw. So either from this thread or from this thread, it has to get a notification that it is done deposit. Then it is going to, after getting that notification, it is going to update the details. Right. So this gives a clear picture of the thread life cycle. Right. The same thing is explained here in the another slides also. Now, in a descriptive format, we given the explanation here. So here you can see first one is the new state. A new thread begins its life cycle in the new state. It remains in this state until the program starts the thread. It is referred to the born state of the thread. Right. In this state, code has not yet been run and the execution process is not yet initiated. Just the thread was created, but the execution process is not yet initiated. Next, second state is active state. The thread that is a new state by default gets transferred to the active state when it invokes starts method. If we invoke a start method, it automatically comes to the active state. So active state contains two substates. One is runnable state and other is running state. I already said you that runnable state is different from running state. Runnable state means ready to run. Ready to run. Right. After ready to run, then only it goes into the running state. Okay. So now after a newborn thread is started, the thread becomes runnable. When I invoke the method start, it comes into the runnable method. In this state, the thread is ready to run. In this state, the thread is ready to run. The thread scheduler has to provide thread time for that runnable state preserved thread. Here, thread scheduler is there. This thread scheduler gives time slices for all the threads which are created. So at which time that particular thread has to be run. So the thread scheduler gives the time slices. According to those time slices, this runnable state thread comes into the running state when it gets its time. So here first thread is getting high priority, which is the first time slot. After the completion of first thread, second thread goes, third thread goes. Like that, when the thread gets its time, it goes into the running state from runnable state. Right. Now, what is running state? The thread is in the execution. It is executing its task. Running state means the thread is executing its task. When the thread receives the CPU allocated by the thread scheduler, it comes from runnable state to the running state. Right. Based on the time slice expiry, so the thread moves from running state to runnable, runnable to running periodically. Okay. Next state is waiting or blocked state. So sometimes a thread has to finish some work or it has to wait for some other resource. In that case, it will be put into the waiting state. Sometimes some thread may be completely blocked. Right. So that is to be called as waiting state or blocked state. So here just example is given. Nothing is there. Next, timed waiting state. Some cases, the waiting state is defined with some interval of time. So it has to wait for 2 milliseconds or it has to wait for 3 milliseconds. So after the completion of 3 milliseconds, automatically the thread comes into the runnable state. Then when the CPU is allocated, then it comes into the running state, it runs. Right. So this is to be called as timed waiting state. And finally, terminated state. So whenever the thread completes its task, it comes into the terminated state. So if it finishes its task, it is to be called as normal termination. But sometimes the thread may be terminated due to some unusual events such as segmentation paths, exceptions. So such kind of termination is to be called as abnormal termination. Terminated thread means that the thread is dead. It is no longer available. Right. So these are the different states which are present in the thread life cycle. Right. Next, we want to see what is main thread. So every Java program contains a main method, right? That main method itself is to be considered as the main thread. Suppose if you create a user-defined thread in a Java program, 2 threads will be run parallelly. The main thread runs and the user-defined thread will run. Right. In general Java applications, if you write the main method without creating any thread, either by using thread class or runnable interface, only main thread runs. Right. Whatever the Java main method that we are creating, with that main method, the main thread will run. Right. Now, after that, how to create user-defined threads using Java. Right. Here, there are 2 ways of creating the threads. One is by extending the thread class and other is by implementing the runnable interface. Here, thread class, it is a predefined class and runnable is an interface which is also a predefined interface. So this thread class or runnable interface are not defined by us. These 2 are the predefined. One is class and other is interface. Now, how to create a thread by extending the thread class, right? For creating a thread by extending the thread class, we can use 4 constructors of the thread class. Here, the 4 constructors are just simply thread which takes runnable interface object as the parameter, thread which takes a string as the parameter, thread which takes both string and object of the runnable interface as the parameter. So any of these constructor can be used to create a thread by using thread class. If you see, you can clearly understood if you see the example. Now here you can see how to create a thread by extending the thread class. Here you can see, so I imported the libraries, whatever I need. Now here I am writing a class, so which I made it as a public, no need of doing it public, but here I am writing it as public class. Public class, here I given class name as GFG. So this extends thread. When I created a class by extending this predefined thread class, it indicates that I am creating a thread. Okay, that is new thread will be created here. Now I need to make it run. That create a new thread, I need to make it run. So for that, what the methods are available? Start is one method, run is another method, and some wait, sleep, some more methods are there. So for making it run, right? Now, when I called the run method, automatically the start method will be invoked. Actually, when I call the start method, the thread comes into the running state. The thread comes into the running state. When I call the run method, here when I call the start method, the thread comes to the runnable state. When I call the run method, the thread comes into the running state, right? But if I directly call the run method, automatically start method can be invoked. That is, the thread comes into the runnable state, then it comes into the running state, right? So that's why directly we are writing run method. And here we are calling run method without using the start method. So no need of specifically writing the start method. When I write the run method, automatically start method can be invoked. Now here we written just in this thread, I want to print this statement. That's why for simplicity, I have written only one statement. That statement is written. Now here I have written a main method. Now in this main method, I created object for my class and I called the run method with that object. So here we are invoking the thread. Okay. So whenever we run this program, we'll get this statement as the output. So whatever the statement we have written here, this statement will be printed as the output. So this is a way of creating a thread using thread class. Now, how to create a thread using runnable interface? Let us see. This is the way of creating thread using runnable interface. Same, here I have written a class GFG, but since it is the interface, I cannot write it as extends. I can write it as implements. GFG implements runnable. So here this run method is available in both thread class as well as runnable interface. In both these, I have. If I am extending the thread class, the run method is overridden here. If I created the thread with runnable interface, the run method which is present in runnable interface will be implemented here. So I think that you understand. The thread class contains run method. In the same way, runnable interface also contains run method. Now, in case of thread class, the run method is a normal method. Some implementation is provided here. But in case of runnable interface, since it is an interface, here run method is an abstract method. Here run method is an abstract method. So whenever we created a thread using thread class, In that case, whatever the run method which is present in the thread class is overridden. Here, overriding concept is occurred. Right. The same run method is invoked to get initialization of the thread, to make the thread running. Right. Whenever I created a thread using runnable interface, here the run method is abstract method. Just only method signature present. Method body is not present here. We are writing the method body here itself. We are our own method body we are writing. Thread is running successfully. That I want to create. So that's why I have written here. Now I created an object for my class, and I created a thread with that object. We are initializing the thread, and a thread object, whatever the thread object we have taken, that thread object is initialized, and then we are calling the run method. So whenever we call that run method, the thread is running, and this statement will be printed automatically. Right. These two are the ways of creating threads. So one is using thread class and other is using runnable interface. Right. Next, thread priorities. What about the thread priorities? So every thread is in Java is having some priority. Every thread in Java is having some priority. So that priority may be a default priority which can be given by which can be assigned by the JVM itself, or it may be a customized priority which is set by the programmer. Suppose I created one thread. So for that thread, the priority is given as 6 by the JVM. JVM given its priority as 6. But I want to make my thread as its priority as 2. So I can give 2, which is to be called as customized priority. That can be set by the programmer himself. Right. Now, priority of a thread describes how early it gets execution and selected by the thread scheduler. So which is having highest priority, that highest priority thread will be given the resource first by the thread scheduler. Right. So how early it gets execution, that can be described by the thread priority. Now the valid range of thread priorities is 1 to 10, and where 1 is the min priority and 10 is the max priority. So non-priority will also be there. The non-priority gives 5. Right. Now here you can see what about the thread priority values. So here you can see first one is thread dot min priority. So here value is 1. So if I implement this method, it prints as 1. If I implemented non-priority, it will be printed as 5. If we implemented this max priority, it will be printed as 10. Right. Now here, these are the predefined priorities. Min, norm, max priorities are the priorities assigned by the JVM, predefined priorities. But user can assign some priority for his own thread. So in that case, what the methods I use, get priority and set priority methods can be used to get the priority of the present thread, or to set its priority to a user defined value or a to customized value. Right. Now get priority method is used to get the priority of the thread. That is, what is the priority assigned to that. That value can be obtained by using get priority method. Set priority method, which is used to set the priority of the thread. Suppose if I want, actually it is given a value 6. If I want to make it as 1, I can make it as 1 by using set priority 1 method. Right. So I hope that you understand priorities in the threads. Get priority and set priority methods
Yes,
also.
ma'am. Yes, yes.
Right. Next, we are going to see here on priorities, we have written a small program. Let us see here. Here I have not written the run method. Actually, I need to write the run method here. Now, my thread extends thread. Here I need to write the run method. Just for simplicity, I have written this program here. Now I have written my class, and here I have written my main method. Now I want to print what is the priority of the thread, current thread assigned. Now I want to set the priority. Now its priority can be set. Now here I created a new thread and I want to get its priority. After setting the priority, I want to get its priority, right? So here I created one thread. Here I created another thread. This thread priority, I want to set it as 11. This thread priority, I want to set it as 7. Now the new thread is created. Now I want to get the priority of this new thread. So here another thread is created to get, I want to get the priority of that thread. So like that I have written a simple program which shows the priorities of the threads. Next, so here you can see one more method, one more program that explains the priorities. Here I written the main method as well. So here this is my class which creates the thread. Here I have written the main method. Now here you can see. So here we are creating the class object for the class what I have. Now I want to set the priority of this as min priority. Now here I want to print that priority. Now again I try to make it as a norm priority and try to print it. Again I want to make it as max priority and I want to print its value. Or otherwise, not only this min priority, norm priority and max priority, if you want to set your value, any of your value. Here min priority means 1, norm priority means 5, max priority means 10. So or otherwise, if you want to set your thread with a priority value 7, you can give. If you want to set your thread with a priority value 2, so you can give using the set priority method, right? So this is about the priorities of the threads. Now, till now, we seen that creating of a single thread. So how to create a single thread using thread class and how to create a single thread using runnable interface. Those things that we seen. Now, if you want to create multiple threads in your program, how you can do that? What is the main purpose of multi-threading? Where, in which types of applications we can use this multi-threading mainly? That we are going to see here clearly, right? Now, multi-threading is a programming concept in which the application can create a small unit of tasks to execute in parallel. So, not a single task. A unit of tasks can be created to execute in parallel. Those tasks are executing in parallel. If you are working on a computer, it runs multiple applications and allocates processing power to them. Now, a simple program runs in sequence and the code statements executes one by one. This is a single-threaded application. But if the programming language supports creating multiple threads and passes them to the operating system to run in parallel, which is to be called as multi-threading. So, multi-threading means it is a programming concept where multiple threads can be created and all these each thread can do its own task and all these tasks can be run parallelly. That is to be called as multi-threading. That is to be called as multi-threading. Right. Now, here you can see an example for how to create multiple threads using thread class. How to create multiple threads using thread class. See here, so I have taken a multi-threading demo class. Here, this is entirely my class name. This extends thread class. So here, whatever the run method which is present in the thread class is going to be overridden here. Now, I want to try this statement, display the thread that is running, which thread ID. So every thread is having its own ID. Which thread is running that I want to print. So that's why here I am writing thread plus I want to get the ID of the thread and I want to print is running. So here it prints the number of, that is the ID which is assigned to the thread, right? Catch exception. So here, since I want to verify whether there may be any exception occurred in the creation of thread, that should be catched. So that's why here I have written catch. And here directly I have taken exception because I don't know the name of the specific exception. In that case, we can take the superclass. So that superclass is exception. And here I want to print a statement exception card, right? Now here I have taken a class for writing my main method. Now this is my main method. Now here I want to create multiple threads. So here I have taken n is equal to 8. That is, I want to create 8 number of threads. 8 threads I want to create. So how I want to make them execute? So for I is equal to 0, I less than n, I plus plus. Here multi-threading demo object is equal to new multi-threading demo. That is, for this class, I created an object here. Now here, just I call the start method. That is, I want to put all these threads into the runnable state. Right. Now here, whenever I call that start method, or you can call directly run method also. Earlier you call the run method without doing the start. You can call run method also. So the threads can be run, and here you can see the output. Thread 15 is running, thread 14 is running, thread 16 is running. Like that, based on their priority, they can be assigned the time slice by the JVM. Right. So here it prints the thread ID. Thread 15 is the ID, is running. Thread 14 is the ID, is running. Thread 16 is the ID, is running. Like that, based on the priority assigned to that particular thread, the threads running will be started. This is the way of creating multiple threads using thread class. Now, the same can be written by using runnable interface also. Now, the same program, I converted it to runnable interface. Here you can see multi-threading demo implements runnable. Here the method run, which is present in the runnable interface, can be implemented here. Now here I want to get the thread ID. So I have written like this: thread plus thread dot current thread dot get ID and is running. Here I want to monitor these statements, whether there may be an exception occurs. If any thread is not created, in that case, that exception should be handled. So for that, I have written it in try statement. And here, whenever if the exception is occurred, that should be catched. So that's why here catch statement I have written. Next, here I want to write a main method. So here I have written a class for main method. Here I have written main method. Now here also I want to create 8 threads. Now thread object is equal to, so a new multi-threading demo. So with this thread, I created an object for multi-threading demo. So for this, I created an object. Now object dot start. So here we invoke those threads, whatever the threads created, those threads are invoked. Right. Now here you can see the output. Thread 13, 11, 12. So based on the priorities assigned, those threads will be run. So this is a way of creating multiple threads using thread class and runnable interface. I hope that you understand these two also. Till now we see, so what is a thread? So what are the, how to create thread using thread class, how to create thread using runnable interface, and what about the thread priorities, and for setting thread priorities, we've seen get priority and set priority methods. And also we talked about multiple threads creation. So that multiple thread creation also by thread class as well as runnable interface. So up to this we talked, right? So next, I want to explain you what is the difference between thread class and runnable interface. Now, if we extend the thread class, our class cannot extend any other class. So since Java doesn't support multiple inheritance, you already know that one. So I cannot write like this. So if it is my class A extends thread, here I cannot write another class. Since so this is the class and this is the class. extension of two classes by a single child is not possible in Java, right? So, but in case of runnable interface, our class can extend other base class. That is, here I can write class A implements runnable interface extends P. I can write like this. So this interface is implemented and this class is extended by A. Like that I can write. Right. So we can achieve basic functionality of the thread by extending the thread class because it provides some built-in methods such as yield, interrupt, which are not available in runnable interface. Some basic methods are not available in runnable interface, but they are available in thread class. Now, using runnable interface, runnable will give you an object that can be shared among multiple threads. So whatever the object given by the runnable interface, that can be shared among multiple threads. And also we can see here, what about those yield, some methods which are available. So what about those methods that I want to explain? Yield method can stop the currently executing thread and give a chance to other waiting threads of same priority. Suppose thread 1 is having 5 priority, thread 2 is also having 5 priority. Now the resources are used by the thread 1. Now if I use the yield method, so this method stops the execution of the current thread and it gives a chance to another thread which is having the same priority. Next, join method. Join method allows one thread to wait until another thread completes its execution. It means that it waits for other thread to die. Other thread completes its execution. Means if it is completed, its execution means it can be terminated. It becomes dead. So if I return join method for any thread means it needs to wait till the thread is die. Whatever the thread currently running, that is die. So after that, if I write join method after the termination of this thread only, this will get the resource. The thread is get resource. Sleep method can be used to pass the execution of the current thread for some specified time of milliseconds. For some specified time, if you want to stop any thread, if you want to pass the execution of any thread, in that case, I can use sleep method. Sleep method is used to make sleep the thread, not die the thread. So sleeping is different, dying is different, right? So I hope that you understand these three methods. Next, so here I'll show you an example program. So for creating 3 threads, first thread displays a message, good morning, for every 1 second. The second thread displays a message, hello, for every 2 seconds. And the third thread displays a message, welcome, for every 3 seconds. So how to create? So here I need to create 3 threads. One thread should print the message, good morning. Another thread should print the message, hello. Another thread should print the message, welcome. But I have given that waiting times also. This thread will not print continuously good morning. This prints good morning after every 1 second. For every 1 second, it prints one good morning statement. For every 2 seconds, it prints one hello statement. For every 3 seconds, it prints a welcome statement. So like that, I need to write 3 threads. I need to write 3 threads which are to be parallelly working. So that I want to explain. So here you can see the program. So class my thread extends thread. So here, since I want to print some message, here I am taking string message and int time also I am mentioning. So here I have taken the constructor of this class my thread, whatever the message and the time I defined, those two I am passing as parameter. So for my thread, whatever the values I am assigning for message and the time, those values will be given to these instant values. Okay, that's why I have written this dot message. You already studied about this keyword. So what is this keyword represents? This keyword always represents the current instance, right? These are the instance variable. These are the parameters. You should get the difference between those two. These are the instance variables. These are the parameters, right? Since both are having the same name, here for differentiating instance variables and parameters, I need to use this keyword, right? This dot message, which indicates this one. This dot time, which indicates this one. For these two, what I am assigning? The parameter values I am assigning. This is parameters. Whatever the value I given to this message, that value is assigned to this. This means this. So whatever the time value I am given to this, that is coming here. This is assigned to this. What is this? This is nothing but this. Right. Now here in this thread class itself, I am writing run method. I am overriding run method. So while true, what I want to do, thread dot sleep time. So I said that 3 threads are given 3 different times. One should print after every 1 millisecond. Other should print after every 2 milliseconds. Other should print after every 3 milliseconds. So that's why each thread is having its own time. So that's why thread dot sleep time is given, and which message, each thread is having its own message. Which message that thread has to print, the message should be printed. And here I want to, if any exception is found, I want to print that exception. That's why I have written them into the try, and here I have written catch statement, and here whatever the exceptional statement I have, that exceptional statement I want to print. Right. Now, up to this, I created a thread. But for making it run, I need to create a main method. Right. Now here I'm going to print, I'm going to write the main method. So here you can see public class Vignan, public static void main. Now here I created new threads, 3 threads I created, thread T1, thread T2, thread T3. Now this is its constructor, my thread constructor. For that constructor, one is good morning message after every 1 millisecond, hello message after every 2 milliseconds, welcome message after every 3 milliseconds. Now I started thread 1, thread 2 and thread 3. 3 threads I started. Right. Now these 3 threads will start execution, and they will print as per our requirement. Right. I'll show the execution later after the completion of syllabus. I'll show the execution, okay, of this program. Now, this is another program, so which creates 4 threads. First thread should print a message 1 after every 1 second. Second thread should print a message 2 after every 2 seconds. Third thread should print a message 3 after every 3 seconds. Fourth thread should print a message 4 after every 4 seconds. Right. Now, that should be created using runnable interface. Earlier, we created using thread class. Now, I want to create using runnable interface. Now, here you can see same, whatever the basic code that I have, I need to write that basic code, thread creation, everything, I know that. I need to write that one. How to write the main method I have represented here. Public static void main, thread T1 is equal to new thread, a new my thread of 1000, 2, 2000, 3, 3000, 4, 4000. I call all the 4 threads. Right. Just this is the simple way of starting the multiple threads which should be run concurrently. Now, this is another program which prints one thread should print even numbers, other thread should print odd numbers, right, using thread class. So here you can see. So here I created through 2 threads. This is even thread, this is odd thread. So this is the logic for printing even numbers. This is the logic for printing odd numbers. I want to make these 2 threads execute parallelly. Now here I have written the main method. Now here you can see thread T1, thread T2. I created. Now I invoked both the threads which can run parallelly. Right. Next. So here the next concept is thread synchronization. Thread synchronization means, suppose for example, same whatever the bank application we considered earlier, I'm giving that same example for explaining the synchronization. Now I created thread for deposit. I created thread for withdraw. Two threads I created. This is one thread and this is another thread, right? Suppose initially my account contains zero balance. Initially my account contains zero balance. Now for this, account updation is also created. Another thread, account updation is also created. So since initially my account contains zero balance, if I want to execute withdraw, is it possible to do withdraw without having any amount in my account? No, it is not possible. So first I need to do the deposit thread. I deposited an amount 1000. That should be updated. 1000 is updated. Then I need to do withdraw. After doing withdraw, again it should be updated. So like that, there is a sequence. But if normally I created these threads, the methods will not work synchronously, will not work sequentially. After doing the withdrawing, they can do deposit, but it is not possible here. After doing the deposit only, I need to do the withdraw, right? So for synchronizedly working, for making them to work synchronizedly, I can use this thread synchronization. Suppose here I given one more example. If multiple threads try to write within a same file, then they may corrupt the data, because one of the threads can overwrite the data. While one thread is opening the same file, at the same time, another thread might be closing the same file. There is some interruption is there. One thread is trying to open the file, but other thread is trying to close the file. So which operation has to take place? There is no synchronization here. That's why two threads are doing such type of activities, right? So I need to make them work synchronizedly. So for that, what we need to do, if it is an unsynchronized way, unsynchronized method, how it will be done. So here you can see the example. I want to take a print table method. I want to print the table. Okay. So which table I want to print? Two table I want to print. Two table I want to print. And up to 5 values. And then 2 1s, 2 2s, 2 3s, 2 4s, 2 5s. Up to that I want to print. So for that I have created a thread and I have written method. So here this is the logic for printing the table. Here this is the thread creation for printing the two table. Okay. Now I have created another thread for printing the 5 table. 10 table, sorry. Here 10 table is printing. This is the main method where I started the two threads. One thread is going to print the 2 table and other thread is going to print the 10 table. So if the method is not synchronized, in that case, how the tables will be printed, how the table values will be printed, let us see. These two threads are not working synchronizedly here. Actually, how it should print? It should print first 2 table. Next, it should print 10 table. If they are synchronizedly working. But here it is not working synchronizedly. That's why it is giving like that. Now, if you make the method as synchronized, here we are using the keyword synchronized. before this method. Then the two threads work synchronizedly. Same program I have written. Here you can see the output. So first 2 table printed, next 10 table printed. So this is about thread synchronization. This is about thread synchronization. So I hope that you understand all these concepts. So can we go for running some of the programs on threads?
Yes, ma'am.
Yeah, I'll show my screen. Right. Is it visible? Online compiler?
Yes, ma'am.
Right. So first I'll show you how to create the thread using thread class. The running of program, how to create the thread using thread class. So here you can see the same program what we explained earlier, the same program I'm explaining. So here I created a thread GFG using the class GFG that extends thread. Here I created a thread with the name G1. Right. Here I have initiated the run method from thread class. Here just thread is running. Here I invoked the run method. Now here you can see that now thread started running. Here you can see the output. Whatever the thread we are giving, that started running. Suppose if I want to create the thread using runnable interface, what I need to do? So here you can see. So here just implements runnable. Here we changed that one. Here we created the thread. Right. Now here you can see. Thread is running. So here it is showing one error because of I missed that closing braces. That's why it is showing an error. My main method is closed. Then my class should also be closed. Now here you can see. Now thread is running successfully. So here only one thread is created. Right. So if I want to create multiple threads, now just I want to, before that I want to show you thread priority. Just I want to show you the thread priorities also before going to that multiple threads. Now here you can see my thread extends thread. Here run method is there. And here I want to set the priority with min priority. I want to set the priority with norm priority. I want to set the priority with max priority. For every setting, I call the get priority method to know whether that particular priority is set or not. So here you can see. First I set for min priority. What is meant by min priority? Min priority is nothing but 1. Right. Now, when I call the get method, its priority is given as 1. Now, norm priority, I set it for norm priority, 5. I set it for max priority, 10. Now, if I want to change its priority to 8, now let us see what happens. Here you can see 1, 5, 8. User defined values can also be given. Now, here I want to set its priority to 2. Here I want to set its priority to 6. Let us see what happens. Now here you can see 2, 6, 8. The priorities were set by the user, not the default priorities. Right. Next, I am going to show you multiple threads, creating multiple threads using thread class. Now, so this is the creation of multiple threads. So how many threads that I want to create? 8 number of threads I want to create. right? All the threads are started here in the for loop, right? Now, here let us see how these 8 threads are running. Here you can see. First, I want thread get ID. Its ID is 15. Thread 15 is running first. Next thread 17 is invoked. Next thread 14 is invoked. Next thread 12 is invoked. So like that, 8 threads are created, 8 threads are running. Right? Do you understand this? Multiple threads are created.
Yes, ma'am. Yes.
Yes, right. Next, we can see one more example, which I shown for waiting, thread waiting. That I want. Now, see here, I created a thread with my thread class. Now, I want to create 3 threads here. One thread should print one message, other thread should print other message, other thread should print other message. Whatever the example we see in here, this is the example. One thread should print good morning, other thread should print hello, other thread should print welcome, right? For that, I have written the program. So here you can see 3 threads are created, 3 threads are invoked, right? Now, let us see how this program is running. See, first thread printed good morning. After 2 seconds, this one. After 1 second, good morning. After 3 seconds, welcome. After 1 second, good morning. After 2 seconds, welcome. After 1 second, like that. Like that, it printed, right? So here the sleep method is working. Whatever the time we given, up to that the thread is working. Then it up to that the thread is waiting. Then it is printing the statement. Right? Do you understand this one? How this is working?
Yes, ma'am.
Yeah. So I hope that with this we explained everything. So do you have any doubts to talk?
No, ma'am. Next week I'll go through this class and again
Yeah.
I'll.
Yeah. So practice more examples. Then you can clearly understand. Right?
Yes.
Okay, right. Can we wind up?
Yeah, ma'am. Thank you.
Thank you.